안녕하세요. 때 에드맨 카페입니다. This time we're going to discuss solutions to exercises in Lecture 5. So the first exercise is to determine whether the ordered pair 8, 5 is a solution to the following system. 5x minus 4y equals 20, 2x plus 1 is equal to 3y. So what we're going to do here is to substitute 8, 5 to these two equations and determine whether it will satisfy the equation. If it does, then it's actually a solution to this system of equations. Let's see, we substitute this time x equal to 8 and y equal to 5 so that we have the following. X here is replaced by 8 and y is replaced by 5. So we have 40, 5 times 8 is 40, then 4 times 5 is 20. So we have 20 is equal to 20 is true. But we also need to verify the other equation. And we substitute it to the other equation. We have 2x plus 1 is equal to 3y. So we let x be equal to 8 and y be equal to 5 here. We have 16. 2 times 8 is 16. And 3 times 5 is 15. So 16 plus 1 is equal to 15. We need to say 17 is not equal to 15. And because this is false, then we say that the ordered pair 8, 5 is not a solution to the given equation, to the system of equations. The second exercise is to solve the following system of equations by substitution. So for the solution, we can substitute 1 to 2, and solving for y, we have the following. That is, we have here 4 equals, you let x here be equal to y plus 3. So you have 3 times x. So you have 3 times y plus 3 minus, you have 2 times y. And then distributing 3 to y plus 3, we have 3y plus 9 minus 2y here. So 4 equals y plus 9. Y therefore equals 4 minus 9, which is equal to negative 5. So we had solved for y equals negative 5. And then the next step is to substitute y equals negative 5 to 1 so that we have the following equation. That is, we have x is equal to y plus 3. So when x equals y plus 3, so x now equal to y is replaced by negative 5. So you have plus 3, x equal to negative 2. So the solution to the system is the ordered pair negative 2, negative 5. Therefore, the system is independent. Now, for the sketch of the following systems of equation, since we are given x equals y plus 3 and 4 equals 3x minus 2y, for the second equation, the first equation is represented by this red graph here, linear graph, and the second equation is represented by this blue graph here. And how did we arrive at this one? We have the following table of values. That is, when x is equal to negative 3, for the red graph, which is y equals x minus 3, we have negative 3 replaces x here, minus 3, so we have negative 6. So you have negative 3 here, and you have, the point is at negative 6 also. So you have this point. It's a red graph. When x is equal to negative 2, we have x is negative 2 minus 3, so we have negative 5. So negative 2 here, and then y is negative 5. So this one, negative 5. When x is negative 1, we have negative 1 minus 3, so we have negative 4. So negative 1 And then we have the value for y is here, negative 4. And down the line, when x is equal to 0, we have negative 3. So when x is equal to 0, we have negative 3. So this one is the linear equation x equals y plus 3, or you can rewrite it as y equals x minus 3. Y equals x minus 3 there. The blue graph here, the blue linear graph, we had solved it from this equation. 4 equals 3x minus 2y. So solving for y, we have y equals 3 over 2x minus 2. So when x is equal to negative 3, we have 3 over 2x minus 2. Replacing x by negative 3, we come up with negative 6.5. So the blue line here, when x equal to negative 3, then y is negative 6.5. So it's somewhere here, negative 3. So somewhere here, negative 6.5. Okay, when x is equal to negative 2, we have negative 5. X is negative 2, we have negative 5. When x is 0, we have negative 2. When x is 0, we have negative 2. So again, you can verify this table of values so that you can sketch the following graph. And the point of intersection this time from here is the given ordered pair, which is negative 2, 5. X is equal to negative 2 and y is equal to negative 5, which can be seen here. You have negative 2 and you have negative 5 here for the x values. For the x value, negative 2, you have the y value, negative 5 for these two equations. So that's the solution set of the system of equations. So we are to solve the third exercise, that is, solve the system of equations by addition. Given x plus 3y equals 8, and equation 2 here is 3x plus 5y equals 10. So for the solution, we eliminate x by multiplying negative 3 to 1, then name the new equation 3. The next, add the two equations 2 and 3. So here we have negative 3 times x plus 3y equals 8. That is, we multiply negative 3 to 1. And then we try to simplify this and come up with the following. That is, negative 3x, negative y equals 8 times negative 3 is equal to negative 24. And then add 2 and 3 so that we have, this time we have 3x plus 5y equals 10. That is our 2. And since our 3 is negative 3x minus 9y equals negative 24, so we have this. So adding them will give us, you have, this is 0 here, and 5y minus 9y is negative 4y, and 10 minus negative 24 is negative 14. So we can solve for y, and we obtain y by dividing both sides by negative 4. So y therefore equals 7 over 2. Then we substitute y equals 7 over 2 to 1. That is following. We have x plus 3 times 7 over 2 equals 8. Because our 1 is x plus 3y equals 8. So solving for the value of x, we have x plus 3 times 7 over 2. 3 times 7, that will give us 21 over 2. There, that's equal to 8. So here, we have it here. We have the following. Is x plus 21 over 2 equals 8. And to say x equals, we have 8 minus, subtract both sides by 21 over 2. So that our x is now equal to negative 5 over 2. Why? We have 2 times 8 will actually give us negative 16. I'm sorry, 2 times 8 will give us positive 16. So we have negative 21 over 2 is x equals negative 5 over 2. So the solution to the system is now the ordered pair negative 5 over 2, 7 over 2, meaning to say the system is actually independent. And for the sketch of this, so for the graphical solution, we have the following: x plus 3y equal to 8. The following are the table of values. When x is equal to negative 4, y is equal to 4. When x is negative 3, y is equal to 3.67. When x equal to negative 2.5, y is equal to 3.5. You can actually solve for the value of y here when we have x. Similarly, when we try to solve for, so this is the graph. You have x plus 3y is equal to 8. That is, when x is equal to negative 4, try to see, when x equal to negative 4, y is equal to 4. When x is negative 4, we have the red one, so you have negative 4 also. When x is equal to negative 3, we have y is 3.67, so somewhere here, 3.67. When x is equal to negative 2.5, so the red graph is, we have here also 3.5, technically 3.5. When x is equal to negative 2, the value of y is, red graph is 3.33, somewhere here. And when x is equal to negative 1, here we have y is equal to 3. So this one. When x is equal to 0, we have 2.67. Here, this one. So this red graph is the graph for x plus 3y is equal to 8. On the other hand, the graph for this one, 3x plus 5y equals 10, is given by the following values. That is, when x equal to negative 4, y is 4.4. So negative 4, y is equal to 4.4. So somewhere here, the blue graph, 4.4. This is 4, so 4.4 is somewhere here. When x is equal to negative 3, so the blue graph here, negative 3, we have 3.8. So here, negative 3, so we have 3.8 here. When x is equal to negative 2.5, negative 2.5, this one, your y is 3.5. This. So notice that the point of intersection is this one. Meaning to say, the solution set is the set containing negative 5 over 2, 7 over 2. This one. Which is basically this negative 2.5, 3.5, and you have negative 2.5, 3.5. That's the point of intersection of these two graphs. So the solution to the system is the ordered pair negative 5 over 2, 7 over 2. Therefore, the system is independent. For number 4, you asked to solve the following system equations in two variables. That is 2y minus 2x equals 2, 2y minus 2x equals 6. So for the solution, we can approach this problem in two ways. One is by substitution. So by substituting 2y minus 2x equals 2, we come up with 2x equals 2y minus 2. You have x equals y minus 1. So we make use of this quantity, x equal to y minus 1. And since we derive this from 2y minus 2x, here equals 2, then we substitute it to the second equation, 2y minus 2x equals 6. So that we come up with the following. So 2y minus 2x equals 6. Substitute x here by y minus 1. The result is 2 not equal to 6. What does it mean? The statement is a contradiction because 2 is not equal to 6. And because of that, the system has no solution. Now there's another approach that is a second approach would be to first manipulate equations so that they are both in slope-intercept form. So we first manipulate the first equation, 2y minus 2x equals 2, that we have 2y equals 2x plus 2. We add both sides by 2x. So you have 2x plus 2 here, and therefore when we divide this equation by 2, we have y equals x plus 1. And then convert the second equation, express to slope-intercept form also. And how do we do that? We have the following. You have 2y minus 2x equals 6. You divide the entire thing by 2 and come up with y is equal to x plus 3. So what did we notice here? They have the same slope but different y-intercepts. So for the graphical solution, this is the illustration for y equals x plus 1, and this is the illustration for y equals x plus 3. So therefore the lines are parallel and do not intersect. So for our analysis, writing the equations in slope-intercept form confirms that the system is inconsistent. To say parallel lines will never intersect. Thus, the two lines have no points in common. So for exercise number 5, we are asked to solve the following systems of equations by graphing. 2x minus 5y equals negative 25 minus 4x plus 5y equals 35. So for the graphical solution, we try to solve the first equation for y, and we come up with the following, that is 2x minus 5y equals negative 25. Subtracting both sides by 2x, we have minus 2x minus 25 on the other side and negative 5y here. Dividing both sides by negative 5, we come up with y equals 2 over 5. It becomes positive here. Then you have minus 25 divided by negative 5. It will become positive also here. So y equals 2 over 5x plus 5. And we try to sketch y equals 2x plus 5 by substituting the values x equal to negative 8 and having the following solved quantities. Then to solve for the second equation, we also need to rewrite negative 4x plus 5y equals 35. And we do that by the following solution. We have negative 4x plus 5y equals 35. So 5y equals, you add 4x on both sides, so you have 4x plus 35 here. So y equals, dividing both sides again by 5, 4 over 5x plus 7. Because 35 divided by 5 is 7 here. And then we have the table of values again. We solve for y by substituting x equal to negative 8, which will give us 3 over 5. Negative 7, when x equal to negative 7, y is 1 and 2/5. So for the graph here, we have the following sketch. Let's take a look at the graph here. When x is equal to negative 8, we have the following value. When x equal to negative 8, so we have the red graph here. So we have 1 and 4/5 for y. When x is equal to negative 7, we have y is positive 2 and 1/5. This one, 2 and 1/5. When x is equal to negative 6, we have y is, we have 2 and 3/5. So 2 and 3/5 here. And down the line, when x is equal to 0, y is 5. So when x is equal to 0 here, y is actually equal to 5. As for the other line, which is y equals 4 over 5x plus 7, let's see, when x equal to negative 8, we have y equals 3/5. So when x equal to negative 8, y is equal to 3/5 here. So this one, the red one, the blue one, sorry, the blue one. 4/5. So when x is equal to, let's see, let's just choose negative 5. When x equal to negative 5, we have y is equal to positive 3 here. So when x is equal to 0, y is 7. X equal to 0, y is equal to 7. So in fact, the intersection is at negative 5, 3. This one, negative 5, 3 here, and you have negative 5, 3. So meaning to say this is the solution. That is, they intersect at the point negative 5, 3. So the solution to the system is the ordered pair, negative 5, 3. So the system is actually independent.